Diane mentioned, I'm Rob Robbins, and I've organized this coastal seminar series. It's our first year doing this. This is our fifth in the series. We've just been adding on to them, and stay tuned. We don't know when the next one is going to be, but there will be more coming in the very near future. We'd love to have your input. If there's some coastal topic that you want to see covered, we'll try to find somebody who's doing research on that. A few other announcements. This presentation tonight is sponsored in part by the Cape Hayes Social Club, the Property Owner Association's social club, so thank you for that. If you're interested tonight, about 7:45 after the seminar, if you'd like to join us, we're going to be meeting at Placida Grill. Mary will be there, as well as some of the other members from the Conservancy and from this group. And if you'd like to have some time to, you can have dinner, you can have dessert. It is pay your own way, but if you'd like to join us, you can go to Placida Grill, which is just up the road, right where it turns into a two-lane road, right after Rotunda Boulevard. Placida Grill is on the right, and 7:45 is when we'll be gathering there. And if you'd like to attend that and need more information, just let me know. So anyways, we have Dr. Mary Lusk, and I'll go ahead and introduce her now. I want to say I discovered Mary, but I found out she's actually been here before. She was discovered long before I discovered her over the summer. And I saw a paper that was written, a science research paper that was done, talking about the possible connections between reclaimed water and stormwater ponds and red tides, and I thought that was super interesting. And so I emailed Mary for the full paper, and she sent it to me, and she said, if you have any other questions, just let me know, and I did. And she said, yeah, by the way, I'm actually looking at maybe doing some research down in that area, and if you could help us facilitate that, that would be awesome. And so Mary's actually been doing research. She is doing research now. It's ongoing in this area, and she may talk a little bit about that, but that's pretty exciting as well. Mary is an assistant professor of soil and water sciences at the Gulf Coast Research and Education Center in Wimauma, Florida. She has a bachelor's degree in agronomy and horticulture from Brigham Young University. She has a Master of Science degree in crop and soil environmental science from Virginia Tech, and she has a PhD in soil and water science from the University of Florida. Dr. Lusk is one of the foremost experts on nutrients and how they move through the environment. She is a sought-after speaker around the country on soil sciences. She has contributed as an author to more than 80 peer-reviewed scientific publications on nutrient-related topics ranging from septic system, environmental impacts to wastewater treatment and reclaimed water. Dr. Lusk's presentation will include a discussion of recent findings from the University of Florida researchers regarding the rapid growth of red tide blooms when exposed to nutrients from reclaimed water and stormwater. And the title of Dr. Lusk's presentation tonight is Coastal Water Quality, the Roles of Septic Systems, Advanced Water Treatment, Reclaimed Water, and Stormwater. And she'll be giving a presentation, and then if you can save your questions towards the end, she'll be happy to answer your questions as well. But please welcome Dr. Mary Lusk.
All right, thank you, Rob. Make sure I'm
Turned on.
All right, thank you so much. I'm really happy to be here tonight and happy to see so many of you here. Really great appreciation to Rob and other folks at the Linden Bay Conservancy for the great welcome that you've given me and for opportunity to be here in your area and to do some research on water quality in the Charlotte County and Cape Hayes area. So I'll just jump right in and start talking about my talk tonight. I did have a lot of information. We talk about septic systems and water treatment and water quality and reclaimed water. Boy, that's a lot. So we've got a lot to kind of go over tonight, but I'm going to give you just an overview of the science behind some of these things that we talk a lot about in this area, and the science of water quality and how we know where things are coming from and what they're doing in the environment. And I'm probably going to leave you with a lot of questions tonight, so please feel free to ask questions when I'm done. And let me just jump right in then. So in my lab, we are the Sustainable Urban Water Cycle Lab, and as Rob said, I'm located at the University of Florida's Gulf Coast Research and Education Center in Waimama. We're in Hillsborough County. So I'm not located in Gainesville. I'm at a research center in Hillsborough County. And it's a great place to be because it allows me to do work in urban water quality. You know, Hillsborough County, I'm right there with Hillsborough, Pinellas, Pasco, that very rapidly urbanizing part of the state. So it's a great place to be. So we study urban water in my lab, and just a couple of my students here. But there's a lot of things that we do to water in urban environments that makes water in urban environments different than water in the natural environment. You know, we pull it out of streams so we can turn it into drinking water. And then after that, we turn it into wastewater, so we have to dispose of it. And sometimes after we dispose of it and treat it, we reuse it, right? Like reclaimed water. And we change it. We change how it flows and where it flows. And we pollute it. And we do all these things to it. But hopefully at the end of the day, we also sustain it. So that's why we do the work that we do, is to find ways to sustain water in our urban environments. And here's just a quick overview of the topics that I want to cover tonight. First, I'm going to give you a brief introduction to water supply issues in Florida, and then a brief introduction to water quality issues, because those two are very connected, as you'll see as I talk tonight. Then a very brief introduction to Florida red tide, what causes it and how human activity can affect it. Then we'll jump in and talk a little bit in more detail about wastewater management, septic systems, reclaimed water, and stormwater. And I'll talk some about tracking where pollutants come from, so that that's really important. We like to point fingers. I see it all the time. Everywhere I go in the state, it's those farmers. No, it's those urban people with their bright green lawns. No, we point fingers a lot. And I always say, you know, by show of hands, who has flushed the toilet here today? We all have a piece of the pie. We do. Every single one of us has got a piece of the pie. And one of the things that I like to do in the messages that I give is to point that out. But there are multiple sources of nutrients that cause problems in our urban water bodies, and so we'll talk about that, how we study that. All right, so some big water issues. Harmful algal blooms. We all know that Florida is prone to several species of harmful algal blooms in our coastal waters, and the one that I brought tonight is Carinea brevis, or also known as the Florida red tide. So this is what it looks like under a microscope. Carinea brevis is a microscopic single-celled organism. It is photosynthetic, meaning it takes nutrients from the environment and sunlight to grow, and we often refer to it as just K. brevis. The K. brevis is very ecologically flexible. This means that it can grow under a variety of conditions. That's one of the reasons it's hard for us to control in our coastal water bodies, because it can take just about any sort of salinity we throw at it. It can take different temperatures and different amounts of sunlight. You know, some harmful algal species are really picky. They'll only grow under certain conditions. The K. brevis is like, yeah, whatever, you know. So it's really flexible. That's one of the reasons that it's hard for us. But like all photosynthetic organisms, it requires nutrients to live, and those nutrients are nitrogen and phosphorus. So it has to get nitrogen and phosphorus from its environment to grow. And very important point about K. brevis, this first point on the slide, so that first bullet point on the left there. K. brevis originates offshore, 10, 20, 30, as much as 40 miles offshore in the Gulf of Mexico. If we did nothing on the land in Florida, if we humans did nothing, very likely, from everything that we know about it, it would still be out there in the Gulf of Mexico. It's a natural part of the Gulf of Mexico ecosystem. It originates offshore. Those offshore waters are naturally very depleted in nutrients that K. brevis needs to grow. So through this process of upwelling in the Gulf of Mexico, where deep, cold, nutrient-rich water gets moved upward to displace warmer water that's being moved by ocean winds, surface winds on the Gulf. This deeper water wells up. This deeper water is very rich in nutrients. So when it wells up every fall, it brings all these nutrients with it, and we get K. brevis blooms at that point. And then after that process goes on, those surface winds can then carry those blooms to our coastal environments. So it's really important to remember that it starts offshore through processes that are very likely not being influenced by humans, but then it flows onto our coastal environments, and that's where we can affect it. So it's very likely that once it gets to our coastal environment, nutrients from the land, brought there by we humans, can prolong the bloom or intensify the bloom. So again, we're not causing it because it's coming from offshore, but once it gets to our coastal waters, we definitely do things that make it hard to get rid of, that can prolong it or intensify its severity. Now those nutrients in the land that can be supporting a red tide bloom in our coastal waters can come from a lot of things, like I've already said. You know, again, we've all got a piece of the pie. It can come from wastewaters, septic systems, reclaimed water, fertilizers, anybody that's using fertilizers in the environment, pet waste, soils, leaf litter, and even atmospheric deposition, which is a fancy way of saying the rain. Even rainwater naturally has nitrogen and phosphorus in it, so even those can be contributors to it. And again, it's a natural part of the Gulf of Mexico ecosystem, but once it reaches our coastal waters, it's very likely that we humans are making those blooms more intense and more harmful. Okay, so that was water quality, just very quick overview of red tide. And the next big issue that I wanted to go over was water supply for us in Florida, because again, they're connected in some ways. Right, and this diagram is showing you who uses water in Florida. And when I made this, I thought it was really cute with the water bottles, but in hindsight, I'm like, this is hard to tell what's going on. So I'm going to change this slide next time I give a talk. But let me just explain what's going on here. The most important parts here are the dark blue and the light blue. Dark blue represents percent of water in Florida that's used by agriculture. This next one, the light blue here, represents percent of water used in Florida by public supply. Or in other words, us humans in urban residential settings. Like everyone in a urban residential neighborhood that's on public water. Agriculture as a user of water in Florida is going down. Urban residents as a user of water in Florida is going up. This is being driven by population growth. Most of the population growth in Florida is just from people moving in to urban areas. So more and more and more, we urban residents are the users of water in Florida. And it's projected to continue that trend. When we project out water use across the state, this is on a statewide basis, when we look at future water need out to 2040, it looks something like this. So here's what's going on. The relative size of the circle indicates how much projected future water we'll need in each of those areas of Florida. The bigger the circle, the more future water we'll need in that part of the state. Miami down here is going to need a lot, not so much up here in the northern panhandle part of the state. The blue parts of these circles represent future water need that we know where it's going to come from. We have supplies already in place to meet that need. The orange parts of the diagram indicate future water supply that we don't yet know where that's going to come from. So the good news is there's not a lot of orange on this map, but the bad news is that there's orange on this map. So in particularly right here, what's right here in Florida? Orlando, yeah, Disney, Orlando, Apopka, that area right there, particularly this area right here. We're looking at projected water supply shortages. So where is that water going to come from? We project that by 2040, we're looking at a statewide shortfall of potable water of nearly 340 million gallons per day. It's got to come from somewhere. So where is it going to come from? There's a couple options here. These are alternative water supplies that we can use. First and foremost, we can just conservation, right? We can encourage people to use less water so we can save it. Absolutely, that's something that we need to do and we are doing. We can reuse wastewater. So that's reclaimed water, reusing our treated wastewater. And this is where, remember I said that water supply and water quality are connected in Florida. This is really how they're connected. We have got to use this water in Florida, reclaimed water, because of this issue right here. But as I'll talk about later on, this reclaimed water has some unintended consequences of its use. It still can have some high levels of nitrogen and phosphorus in it. And there are other sources of alternative water supply that we're considering in the state. So let me just talk a little bit about my feelings about conservation. I am all for conservation. but I'm a little skeptical of its ability to fix all of our problems. And this is where my skepticism comes from. So remember back about a year after COVID, maybe you guys heard about this on the news, in Orange County, Florida, they were COVID patients in the hospital were needing liquid oxygen for COVID, for respiratory treatment. But the liquid oxygen was also needed by the Orange County water treatment plant to treat their drinking water. And so the mayor of Orange County made a plea to the public, please conserve water so that we can divert our liquid oxygen to the hospital for COVID patients. And he made this plea, again, please conserve water. This line right here represents the date when that plea from the mayor took place. This blue line is water usage. And you can see that it did go down a little bit, but we needed to get down to here to conserve the water that we needed to conserve to be able to send the liquid oxygen that we needed to the COVID patients in the hospital. We came nowhere near that, even after the mayor went on television and made pleas to the county. So this was just a quick little paper that we published a few years ago on this. But again, I'm skeptical of we humans and our ability sometimes to do the actions that we need to do. So I think that we definitely need teaching conservation, and we need to keep in mind that there's a lot of social components to that as well. We can recognize that conservation is needed all day long, but until we have meetings like this, where we teach people about the need for it, and you guys go out and share that need, we've got a lot of work to do still. So if conservation is maybe not working for us, what does that leave? And I've circled reclaimed water here because I'm going to talk about that a little bit more tonight. But I want you to just keep those two things in mind. Keep in mind what I talked about earlier, the red tide and how much it needs nutrients, and how nutrients from our nearshore environment can be affecting its growth. And keep in mind also that we need to use this reclaimed water because we really have a lot of population growth and need for water in the state of Florida. It's all connected. All right, so with that in mind, I'm going to start talking about ways we dispose of water in the urban water cycle. Let's see, where do we start? So domestic wastewater, you guys probably know this, but it's the wastewater that comes from our homes. And every person in Florida generates about 100 gallons of domestic wastewater every day. So that's the stuff we flush down the toilets, our washing machines, our dishwashers, our showers. It's all domestic wastewater. And it's treated by one of two options: an on-site sewer treatment and disposal system, sometimes called a septic system, or by a central wastewater treatment facility. That would be a sewer. We connect it to a sewer and it goes there instead of a septic tank. About 30% of our domestic wastewater in Florida is treated by septic systems. We're one of the leading states in the country for using septic systems. There's over 2 million septic systems in Florida, a very important means of wastewater treatment for us in the state. I understand there's quite a few of you maybe here tonight have septic systems. Anybody who has a septic system? Yeah, wow. Well, that's a lot. Yeah. All right, so just quickly, how a septic system works. You just flush and it goes away, right? That's how it works. Let me just briefly explain how your septic system works. This is a conventional septic system. There are a couple of options, but I'm willing to bet this is what most of you have got. So a conventional septic system has two parts: a septic tank and a drain field. So all of the waste comes from the home, it accumulates in that septic tank. And this is what the inside of the septic tank looks like, where solids settle down to the bottom. I think we all have a pretty good idea what I mean by the solids, right? Solids settle down to the bottom. Fats, oils, and scum float upward. And in the middle, there's this water, liquid layer that then flows outward. At that point, we refer to it as effluent. It flows outward and goes to the drain field, which is the soil that it looks like this. So in the drain field, there's a bunch of perforated pipes, and the effluent flows through these and percolates down through the soil. And this drain field is really, really important. It is the absolute workhorse of this system. Most of the treatment of all the pollutants in that wastewater effluent take place in the drain field. It's not in the tank. The tank just kind of holds stuff and then sends it on out. Your drain field soil is so important. So, and in order to do the work that that drain field soil needs to do, it needs about 24 inches of unsaturated soil. By unsaturated soil, I mean soil that is just that, it's not saturated, it's not spongy and dripping water, it's got some dryness to it. 24 inches, really important. After your waste moves again out of that septic system, out of the septic tank, and goes to the drain field. There are people who have studied this. It's not a job I would want, but there are people who have studied this. They estimate that every one of us excretes about 2.7 grams of phosphorus per day. And after it goes through this treatment, only about 0.5 grams of it actually exits the drain field, meaning that conventional septic systems remove about 80% of the phosphorus that goes into them. That's pretty darn good. And so they're holding that phosphorus and preventing it from going into the environment. And this is a really complicated diagram. And let me just, all I want you to know from this is that the reason for that is because soils are very good at absorbing nitrogen. So once that wastewater moves through the soil, it holds the phosphorus really well and prevents it from going to groundwater. Now nitrogen is a different story, unfortunately. Nitrogen is just evil. So nitrogen, there's really not a strong pool to hold that nitrogen in the soil. So most nitrogen that leaves the septic tank, or the effluent that leaves that septic tank, is in the form of ammonia nitrogen. Ammonia nitrogen is very quickly converted to nitrate nitrogen in the soil. And that's done by soil microorganisms that are ubiquitous in the environment. Nitrate nitrogen is very mobile in soils. So it moves very quickly, so it reaches down very easily. Or it can get to our groundwater. There's only one process that can remove that nitrate nitrogen. That is the process of denitrification. I thought I had a picture of that. Denitrification simply takes this nitrate nitrogen and converts it to a gas that can escape to the atmosphere. But it needs certain conditions to happen. I think actually I do have a picture. Similar as phosphorus, we excrete about 11.2 grams per day of nitrogen. And the drain field does not do a very good job of holding that, removing that, attenuating that. We end up with almost 70% of it able to make its way to the groundwater. So a conventional septic system only removes about 30% of the nitrogen that goes into them. These systems were never designed to remove nitrogen and phosphorus. They were designed from a public health perspective to treat pathogens. They do a wonderful job of removing pathogens, treating pathogens, and keeping us from contacting communicable diseases from wastewater in our environment. But they were not designed to remove nitrogen and phosphorus. Now, in most cases, that's okay, because even though they weren't designed that way, the environment is still able to take a lot of that. So the soil can remove about 30% of it, and then when it gets into groundwater, it can continue to be treated, continue to be attenuated, and removed. Oh, here's my denitrification picture. So yeah, denitrification is the process that removes that nitrogen from the environment. This can happen in the groundwater. So even if our soil drain field has not removed it all, we can still get this process going on. Take that nitrate and convert it to a gas that escapes to the atmosphere. But it's really important that we have two things in order for that to happen. We need a low oxygen environment, and we need a carbon source. And that doesn't always happen, but if we can create that type of environment, we can encourage removal of that nitrogen from septic systems. All right, so septic systems a couple years ago started getting a lot of press in Florida, a lot of talk. I'm sure you guys are aware of that. It was really driven by issues that we saw in the springs in Florida. We have more first magnitude springs in any state in the country. And you can really see here how septic systems might influence spring systems. So just imagine you've got a septic tank up here and, let's say it's close to a sinkhole or a spring. It's a very easy conduit to get to the groundwater, to get out to surface waters in these spring and sinkhole systems. For example, this is an example of a springs system in Florida. The This is from Weeki Wachee Springs. So Weeki Wachee has been identified as having nitrogen impairments, and DEP, Florida DEP, has identified some sources of nitrogen in that spring system. And septic systems were the first one here, contributing about 30% of the nitrogen is there. But there are other sources as well. And it's like the point that I made earlier. There are multiple sources. Atmospheric deposition, UTF is urban turf fertilizers, farm fertilizers, sports turf fertilizers, livestock waste, and of course wastewater treatment facilities. So through a couple years of study, DEP has pinpointed contributing sources to nitrogen in all of our spring sheds in the state of Florida. And you can see that it varies by springs how much septic systems contribute. So they contribute a lot, say in Volusia Blue Springs over in Volusia County, because it's a very rural area over there. Not so much in Jackson Blue and the Lower Swanee Springs, because it's more of an urban area where there's just not a lot of septic systems. But anyway, I know you guys don't live in a spring system, but I think this is where a lot of the talk started in Florida, a lot of the movement to really look at septic systems and how much they're contributing nitrogen to our environment. When we started this work with the springs, and it started with the springs, and now it's moving to coastal systems as well. So a lot of communities that are coastal, that have septic systems, are starting to try to do work like this and to move in this direction as well. So there are things that we can do to help carry out that process of denitrification that we talked about. One of those is an in-ground nitrogen reducing biofilter. This is an amendment to your drain field. So this would mean going in and putting new layers of material in the drain field to encourage that process of denitrification. It would look something like this. It costs about $5,000, maybe a little more, and it will last for 20, 25 years. It's basically just modified materials under your drain field soil. They provide a zone for nitrification. That's where we're taking ammonia nitrogen and converting it to nitrate. And then we move it through a denitrification zone to get it to convert to a gas that moves out to the atmosphere. So there are things that we can do to those conventional systems to improve nitrogen removal. And this is something that's being considered in a lot of areas, especially in those springs areas. But again, I wanted you to understand that these systems were never designed really to remove nitrogen and phosphorus, but they can do a very good job, even though they were not designed to. They can do a good job of doing that, and there are things that we can do to amend those systems to improve nitrogen removal. Now, are they contributing to problems in our coastal areas like they are in the spring sheds? Really, in my understanding, my opinion, my knowledge of this, the jury is still out on that. We have not done as extensive work for our coastal areas as we've done in the springs. So we can't make numbers like this for our coastal areas. That work is still ongoing, and it's a work of research that we still need to do. Also, let's talk about reclaimed water a little bit. So reclaimed water, former domestic wastewater, has been highly treated and disinfected and then disposed of and reused. If it is not reused, it's just discharged, usually non-beneficially to the environment. Florida leads the nation in reclaimed water reuse, and we lead the nation by a lot. So Texas and California are our only really competitors in that category, and we are way ahead of them at nationally about 884 million gallons per day of wastewater reuse in Florida. Over 60% of that is used for public access, which is what? What do you think that means? I heard towards lawn irrigation. 60-something% of it is just for lawn irrigation in Florida. So, a couple of years ago, we had Senate Bill 64 in Florida. It requires a couple of things for us. One of the most important things that it requires is this non-beneficial discharges will become disallowed. So we're going to eliminate just discharging of that treated wastewater, and we need to find beneficial reuses for it. So, in that need to find beneficial reuses for it, we're really starting to think more and more in Florida about using more and more reclaimed water.
Now, there are some barriers to expanding the use of that, and they're all kind of laid out here for you, but the one that I focus on most is water quality issues. So reclaimed water can still contain nitrogen, phosphorus, maybe some pathogens, salts, microplastics, all of those things. It can still contain some of those things. We need to be careful about how we use that water, both from a water quality, as in downstream water quality perspective, but also just from like our landscape quality perspective. So anybody here a big gardener and use reclaimed water and have salts from that water that maybe affects your landscape, it definitely can be an issue. So that's what we focus on, is that water quality aspect. And as Rob mentioned, we have been doing some work here in Charlotte County. I just today finished all the analysis of the water samples I've been collecting here. So I've not had much time to really analyze and draw up that data yet. Let me just give you some examples. So because of Senate Bill 64 here in Charlotte County's plans for compliance are to upgrade the wastewater treatment facilities to advanced wastewater treatment, which will be enhanced nitrogen and phosphorus removal of wastewater. This will mean that once those upgrades are made, total nitrogen should not exceed 3 milligrams per liter in that effluent, and total phosphorus not to exceed 1 milligram per liter. From samples that I took in March and April of this year, I was looking at 2 different neighborhoods, one that uses reclaimed water to irrigate their green spaces, and another that uses potable. And you can see the numbers in that water, how they differ here. So in the reclaimed neighborhood, we had as much as high as 10 milligrams per liter total nitrogen and almost 4 of total phosphorus. Look how much lower it was, 1.2 and 0.6 for the neighborhood that's irrigating with potable water. So huge difference in the amount of nutrients in those two neighborhoods. A lot of implications of that for the fate of those nutrients in the environment. And this is a neighborhood here close by, I won't name it, but you might recognize it, that uses reclaimed water. And I love this picture because all these green spaces are being irrigated with this high nutrient reclaimed water. And look how close we are out here to the creek, that flows on, to a surface water body that we're concerned about. So let me give you a story of some research that we've been doing on the east coast of Florida. I would love to duplicate this on this side of Florida. So if anybody would like to participate in that or throw money my way, so to do that, I would happily do that. This was done by a graduate student in my lab, Dylan Barr. He's now graduated and gone on to a great job. And let me just show you what he was interested in. So he was interested in reclaimed water overspray. What do I mean by overspray? So overspray is when people are irrigating the lawns, but they're also irrigating the sidewalk and the street and the parking lot, all of those things. That's overspray. Wasteful application. You can see pictures of it here. This is overspray. This is overspray. So Dylan used a drone to fly over when people were irrigating, and he captured images like this. And then we had some image processing software that's able to convert this to an area on the ground. So we could say something like, X square feet of area was wasteful water application. And at the same time that those pictures were being taken, we had these catch cans on the ground. This is called a catch can. And it's graduated, so it reads depth of water. So we could collect water in these while the sprinklers were running. And that would give us a depth of water. So from Dylan's drone images, we have area that's being oversprayed. From this, we have the depth of that water over that area. So we can convert that to a volume of water. And then we analyze the nutrient concentration of that water. And once we have volume and we multiply it times nutrient concentration, we get nutrient load, which is like pounds of nitrogen or pounds of phosphorus. So that's what he did. And let me just show you some data from that. So the first question was, how much are people overspraying? Like when you typically run your sprinklers in a neighborhood every morning, how much of that is just overspray? And he found that on average, it was about 34%, 33.7%. So just a third of all the water that's being irrigated every time in our typical urban neighborhoods. 34% of it is just wasteful. And when we were talking about this with the community, we did a little advertising campaign. we call it hashtag streets don't grow, and hashtag just wet your plants. We don't need this, right? We only need to keep it right in here. About 34%, keep that number in mind. And then he had neighborhoods receiving reclaimed water with different types of treatment. So one of them had advanced treatment. The other one only had secondary treatment. So the water was treated to legal requirements, but there wasn't that advanced level of nutrient removal. And we made some assumptions here. We assume a typical lawn size of 0.1 acres and irrigating about 1 inch per week because that's the IFAS recommendations for Florida. We all know people are probably adding 2 or 3 more inches per week. But we assumed only 1 inch per week. We know that in the South Florida Water Management District where this took place, there are 164,000 some residences that use reclaimed water. So look back at the envelope calculation here, but I think it's a pretty valid calculation. If those neighborhoods are using advanced treatment reclaimed water, these are the pounds of nutrients in that overspray. It's the water that's just flowing down the streets because people's sprinklers are irrigating the streets. Look at these numbers, total nitrogen, 44,000 pounds a year, and that's with advanced treated wastewater. But look what it becomes when it's only secondary only treatment. That total nitrogen becomes 605,000 pounds per year. And again, that's only associated with the overspray. And that's water that's just being gracefully applied to the streets, flowing down the street sometimes, and forever out at night when my neighbors are irrigating, taking pictures, because it's flowing down the street. And I'm thinking about numbers like this. So lots of inappropriate nitrate, ammonia, that's dissolved organic nitrogen, total nitrogen, and total carbon. But two take-home points from this. One is the difference between advanced treatment and secondary treatment. It's a lot of pounds of nitrogen that we can eliminate by instituting advanced wastewater treatment. But the second take-home point is that even with advanced treatment, we still have a lot because people are irrigating the streets and the sidewalk. And the point that Dylan makes is that even if we're not concerned about nutrients, this 34% of wasted water is really not what we need to do in Florida. Remember when I talked about earlier how we're facing a 300-something million gallons a day shortfall? How can we be watering the sidewalks when we face that shortfall? This is a really easy fix. All of you go home tonight and look at your sprinkler heads and telling them so that they're only watering the green space and not the streets and the sidewalks. Just remember hashtag, but just wet your plants.
May I ask a question about the previous slide?
Yeah.
Am I to infer that you have numbers 1, nitrates and NH4, roughly 17,000 pounds with advanced water treatment. Secondary was over 500,000 pounds. Would one correctly infer that secondary only treatment is about 25 times worse?
Yeah, that's a valid. The math is correct there. I didn't do the math.
Yeah, I did that.
If your math is correct.
I'm a high school graduate, so. Thank you. Roughly 25 times worse.
Yeah.
Thank you.
Yeah, so when Dylan did this work, I made him do the calculations like 10 times. And then I did the calculations myself 10 times. Because I looked at these numbers. Hey, it's correct. And this is based on people irrigating only an inch a week. I don't know that I believe that. I think most people are irrigating 2, 3 inches. So,
But it's the
yeah.
it's the relative impact of advanced water versus secondary.
Yeah.
That's the amazing.
Yeah, I mean, it's really, it's one of the take-home points there. It is. So anyway, such an easy fix. Go home, pay attention to your sprinkler heads. All right, so also urban water, we change it. We change where it flows, how it flows, when it flows, why it flows, what's in it. We do all kinds of things. So let me talk about that a little bit. Because I'm in Hillsborough County, I have slides on Hillsborough County, but This is the same spot in Hillsborough County, Florida, 1948 versus 2016. What's the same? Well, a lot of it's the same. What's the same? We see these depressional areas where water accumulates. What's different is that over here, these are natural. Over here, these are human-made stormwater ponds. So in our urban environment, we're trying to do the same thing that nature did 100 years ago. We're doing it with these human-made impounded stormwater ponds. I have some good colleagues at our main campus in Gainesville who wrote a paper a couple years ago on these stormwater ponds in Florida. There are more than 76,000 stormwater ponds in the state of Florida, representing nearly 3% of total urban land cover. Everywhere there's a blue dot on this map, there's a stormwater pond. So how can we ignore the implications of those ecosystems in our urban environment? There's a growing body of researchers and literature that's really focused on these. It's really exciting to me how much work is starting to be done on those ponds. That's one of the things that in my lab we're starting to work on, is understanding the implications of this much water in our state. It's a stormwater pond. So those original stormwater ponds back 100 years ago, they did a lot of things for us. They controlled flooding and they improved water quality by taking up nutrients, and they were just aesthetically appealing. Our modern day stormwater ponds, we hope they do the same things for us. And we hope that because, as you guys, I'm sure you know, what happens on our lawns, every time it rains, it goes through one of those ponds, which can make its way to a stream, which can make its way to our estuaries, our bays, and our coastal water bodies. So that's why it's important. So I went through my urban neighborhood in the whole Tampa Bay area. I started looking for sources of nutrients to stormwater ponds, and I found a lot of them. So let me show you. I took these pictures in like 30 minutes. It only took me 30 minutes to find like 10 sources. So number one, what is wrong with this picture? It's the roof runoff right to the driveway, which goes right to the street, which goes right to a stormwater pond, which goes right to the bay. How easy take this and divert it to the grassy area. Put a rain garden in, put it to the lawn, put it to your flower bed, a tree, whatever. Please don't do this. This one, we talked about this already, but if this is reclaimed water, that's a source of nutrients in our urban environment. This one, this is a lawn. It's not a very healthy lawn. It's mostly weeds. But you know what? I'm more afraid of this lawn than one that's fertilized. Because this is the gutter right beside that lawn. This is a stormwater gutter. You see this right here? Soil, eroded soil on this crappy lawn. Soil is a huge source of nitrogen and phosphorus. So it doesn't have to be turf. If you don't want turf because you don't want to fertilize it, or maybe you have a lot of shade, so turf doesn't grow very well, it doesn't have to be turf, but have something covering that bare soil. Bare soil to me is actually more scary than a bag of fertilizer. Compacted urban soils. What happens when the soil is very compacted? Does water move through it, or does it run off? It runs off. So again, break up that compacted soil, put some compost in, aerate it, and put some vegetative cover over it to encourage percolation. Dog waste station, pet waste, is a huge source of nutrients in our residential environments. This right here, every year when the live oaks start dropping their leaves in like February, March, what do you guys' streets look like? We have a lot of that here. Up in Hillsborough County, it's like piles of it. I'll show you some data. This is a source of nutrients. All right, so we'll talk a little bit about how we figure out which of those sources are most important. Because again, we've got a red tide in Florida. We love to point fingers and say, it's you guys. How do we figure out where it comes from? We use a tool called isotopic source tracing. Let me explain just a little bit of science behind this. Think back to your high school chemistry days. Isotopes. They're atoms of the same element with a different number of neutrons. So remember the atoms in their nucleus have protons and neutrons. Let's talk about nitrogen, for example. Nitrogen has 7 protons in its nucleus. Always, 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 always. If there's a different number of protons, it is not nitrogen. Most cases, it also has 7 neutrons in its nucleus, but not always. Sometimes it can have 8, or only 6. In that case, we have isotopes of nitrogen. So we have atoms in the same element, it's always nitrogen, but because they can have different numbers of neutrons, they're going to have a slightly different number of particles in their nucleus. And that creates a situation where we can have atoms of the same element with slightly different masses. A neutron has minuscule mass, but it does have mass. And so if the atoms have different numbers of neutrons, they're going to be a little bit different in their mass. This is handy for us, because through a process called isotopic fractionation, the microorganisms that cycle nitrogen on Earth prefer the lighter atoms and leave the heavier ones behind. They're like us, they're lazy. So they're going to use the lighter ones and leave the heavier ones behind. So I can go out and collect a water sample, and we will analyze that for the ratio of the heavy isotope to the lighter isotope for both nitrogen and sometimes for oxygen as well. If we're analyzing it for nitrate, which is NO3, nitrogen and oxygen together. And through years of study, very bright people, smarter than me, have learned that when we flip that number back from this analysis and we plot it on a graph that looks like this, oxygen isotope ratio over here, nitrogen isotopic ratio over here. If the nitrate came from, say, rainfall, it's going to plot somewhere up here. If it came from fertilizer, it's going to plot somewhere over here. If it came from the soil, it'll plot here. If it came from manure, septic systems, reclaimed water, it plots kind of over here. So that's exactly what I do. I go out, I collect a sample, I analyze it for these ratios, and I plot it on a graph like this. Your samples that I've been collecting in Charlotte County these last couple of months, I have just sent last week before last, to University of California at Riverside. They are doing this analysis for me. I hope to have the data back in 3 or 4 weeks. And I will make a graph just like this with your waters from Charlotte County. Let me show you some of the data that we've already done. This was done in Hillsborough County, in an urban neighborhood in Hillsborough County. So we did all of that analysis, we plotted it. Here's the final take-home message. More than almost 50% of the nitrate in this particular neighborhood was just from the atmosphere. It was just rainfall. We also had some from fertilizers, from soil processes, and organic nitrogen in the community. It's hard to see on this graph, and I apologize. But in this case, all the little dots represent time when we collected samples during a storm. So this is like, it started raining, and we collected a sample right here. 15 minutes later, we collected the next sample. 15 minutes later, the next, and all the way down. In all cases, you can see we kind of start up here, indicating that early in the storm, most of the nitrogen is coming just from the rainfall. But as we move through the storm, as the storm progresses, we start getting more and more from soils and from fertilizer. And that makes sense, because as the rainfall progresses, the soils become more saturated, right? They get heavy with rain, and the stuff starts to flow out of the soils. So if we're looking at stormwater runoff, our small little 15-minute spits of rain that we get sometimes in the summertime, all the nitrogen in that is probably just from the rainfall. Those long half-a-day rains, those full-day rains that we get that really saturate that soil, we're going to start seeing fertilizers and pet waste and soil influences a lot more. Similar here, this time we're not looking at one rainfall event, we're looking at a whole season. This is a rainy season across here. Biggest thing here, this is crazy. Blue and red are inorganic forms of nitrogen, nitrate, and ammonia. Yellow is organic nitrogen. Take home message here. Early in the season, we see a lot of inorganic nitrate and ammonia. As the season progresses, we see more organic nitrogen in the stormwater runoff. This is probably because it's been a dry season, and dust and things have been accumulating on the streets. And as the rainy season starts, it starts flushing all that stuff off. And then as it progresses, this stuff disappears, and we get more and more influence of organic material, again, from soil flushing out over the season. Okay, so that was stormwater, that's what goes into our stormwater ponds. This is what comes out of it. Again, very early in the season, a little more nitrate, ammonia. Later in the season, all this yellow is organic nitrogen coming out of the ponds, most likely from soils and pet waste and plant material. How relevant is this dissolved organic nitrogen? Can it be used by Carina brevis, our red tide organism? Yes, it can be used very well by Carina brevis. This is some work done by Amanda Mooney Morgan, recently graduated PhD in my lab. Now, Dr. Mooney Morgan, she took effluent from a wastewater treatment plant in Sarasota. That's what MWW stands for, it's municipal wastewater, as well as water from 3 different stormwater ponds in Manatee County. And she incubated it with K. brevis. And in each case, you see this part of the graph where things just spike up, woo, going up. That's K. brevis cells multiplying when it's exposed to the organic nitrogen in those samples. So in all cases, absolutely, K. brevis was able to grow from the organic nitrogen from these stormwater ponds and from municipal wastewater. To me, a big take-home message of this is that stormwater pond effluent is just as bioavailable to K. brevis as is municipal wastewater effluent. We know that this is a source of nitrogen for K. brevis, and pretty good evidence here that it is also supporting growth. The stormwater ponds, what comes out of the stormwater ponds also supports that growth of that organism. So, really important take-home message to me. This is another study, so a different study. This was done on the east coast of Florida. Isotope tracking study, where is it coming from in the Indian River Lagoon? This study was done on canal front homes. So think a home has a lawn and it's just grass, water body, right? So we collected a runoff as it came off these lawns right here, right as it came off the lawn before it went into the water body. And we did isotope analysis on a bunch of different lawns, all numbered here. It's a mixture, right? Remember, so we all have a piece of the pie. There's atmospheric deposition is part of it. Fertilizers and soils are part of it. Here's my story about pet waste. So you notice all of the little purple squares here. This was lawn number 4 in our study. Homeowners in lawn number 4 told us when we started our study, we don't apply any fertilizers. We want to be good stewards of the canal, the Indian River Lagoon. But they did have a beautiful black Labrador retriever that had free roam in the backyard, and beautiful black Labrador retriever never got his pet waste cleaned up. And so when we analyzed runoff off that lawn, guess where? Did I do something funny? Oh, I'm being closed captioned. Guess where it came from?
Is that your person?
This is not. So, again, such an easy fix here, right? What an easy fix. So we told the homeowners, we showed them this data, we told them, and they were so just like, oh, and now they cleaned up their pet waste. So it's such an easy fix. So I tell that story, this is 50 years ago, but I still tell the story every regular. It's an example of using science to indicate a source, showing people the data, and they changed their behavior. They immediately started cleaning up that waste. To me, that is a success story. I think we underestimate sometimes what our pets can do. We should think, how many dogs are in this neighborhood? It should be pretty significant. All right, one more story about stormwater. This was in Hillsborough County. This is a neighborhood, so each of these green plots is a house and a lawn. All these are stormwater drains in the street, and culverts. They all connect and send water to a central stormwater pond. So that's where this study took place. Put a stormwater sampler at the bank of the pond, so that every time it rained, we can collect samples right before the runoff went into the pond. We analyzed it for different forms of nitrogen and the isotopic signatures. And this is some data from it. So blue lines are rainfall coming down, so just the amount of rain. You can see some big storms throughout the season. pink lines are total nitrogen concentration. Big flux of high nitrogen concentration early in the season again, tailors off later in the season. And in this case, we refer to this big flush early in the season as a seasonal first flush. And it makes a lot of sense again. Dry season just preceded this. There was lots of dust and particles on the streets and the sidewalks. All that stuff got washed off. And then we had this the rest of the season, which was just stuff from the community. We also saw through isotopic analysis that this was the big contributor in that community in Hillsborough County. The leaf litter was the problem, really. Not a lot from fertilizers, mostly from leaf litter. Again, easy fix, right? Go out and sweep this up. I have 3 boys, I've raised 3 boys. They're all grown now, but when they were little, when they were teenagers, they did a lot of raking leaves in the spring. So keep that stuff off the street. Some implications of this. Let's just go through these quickly. Oops, move on. The seasonal first flush, just telling us when the nitrogen signal is very strong in stormwater and helping us identify moments for removal. So in this case, that moment right before the onset of the summer rainy season. We also know that there are multiple forms of nitrogen, be it nitrate, ammonia, organic. Organic was really important later in the season, especially in this case, in helping us identify management practices. And we identified, in this case, that leaves were an important source of that organic nitrogen. The streets would mean urban BMPs or best management practices that remove those leaves would be a really important means of reducing the amount of nitrogen in that stormwater. So we have all this nitrogen in stormwater. We want to protect our bays from it because of the tide. So we send the water to stormwater ponds, right? And they remove everything, right? Wrong. Stormwater ponds actually do a pretty good job of removing nitrogen. This is percent removal. We can get more than 80% sometimes in these ponds. They do a lousy job of removing nitrogen. Like, remember I told you nitrogen was evil? It just is. For a lot of the same reason that conventional septic systems do not remove nitrogen, neither do stormwater ponds. So at best, we get like 30-40% removal of nitrogen in those ponds, so that what goes in, almost all of it goes out. It can make its way on to the bay and the estuaries and that kind of stuff. So again, there are 76,000 stormwater ponds in Florida, and they're really not doing much for us in terms of removing nitrogen. There's a big push to improve these. There's a big push to do alternative forms of stormwater management in Florida. We're not there yet, but we're moving in that direction. This is my student Paula. She is working on stormwater ponds in Hillsborough County. She's working on what we call a zombie pond. We call it a zombie pond because it looks really awful. We're hoping to bring it back to life. She's specifically looking at floating treatment wetlands. These are plants inserted in the pond. Their roots go down and take up nutrients and remove those nutrients from the pond. So that's some work that we're doing. I realized that this presentation had a lot of doom and gloom in it, so I wanted to leave it on this side of hope. And a lot of the work that we're doing is trying to find ways to overcome a lot of those problems that we just talked about. How can we make better septic systems? How can we make better stormwater ponds? How can we teach people about pettways and reclaimed water so they control those nutrients and prevent them going into our coastal waters? Hopefully, I leave you with a little bit of hope that we are working on these problems. I think that we're finding the just in conclusion, again, water quality and water supply very connected in Florida. Just like our reclaimed water, we've got to use it because we need to augment our potable supplies. We've got to use it carefully. Wastewater, stormwater, reclaimed water, they're all parts of the water cycle contributing nutrients to our coastal water bodies. And we have very strong evidence that once red tide is on our coastal waters, our human-caused nutrient sources can prolong those blooms. There are multiple sources of nutrients. We cannot point fingers at one person or one source. Conventional septic systems do have little capacity for nitrogen removal. Research is ongoing for coastal systems. For springs, we know a little bit more, but for coastal systems, we're still doing more research on how much they're contributing to the problems. So we're doing a lot of work on advanced wastewater treatment and stormwater pond improvements to hopefully improve a lot of things for us. That was a lot. I have to thank my students, all my students over the years. They've done amazing work. They're amazing. So thank, acknowledge them and thank them. And with that, I will thank you. Thank you for your time.
So thank you, Mike. So we really appreciate you coming.
Awesome.
And Mary will take some of your questions.
Yeah. Yeah, right here.
When we improve our reclaimed water quality, will it also improve the aroma?
That's a great question. Second question, Brandon. I see you in the audience. What will that improve? Smell?
What are we referring to the smell of the pond that the reclaimed water is going in? What aroma
Like
specifically?
irrigation?
Like the sulfur smell?
Oh, that's a different, yeah, sorry. That's a totally different story, unfortunately. That's not a reclaimed related thing.
Yeah.
That is
sulfur.
you're pulling water from the ground that unfortunately is high in sulfur. And I think for a lot of places high in iron, which is why I think some of the
Yeah. So you get all that sulfur bacteria. Which is,
Mhm.
yeah. Probably we might get we're going nitrogen and phosphorus levels down, but we're still gonna have that sulfur.
Right.
Yeah. Did you have a question?
Actually, more of a comment. I live in Rotunda. We have almost 30 miles of canal. We work with Lake Watch, and we worked with Lake Watch for probably 20 years. I don't know. Bob Winter, how long have you been sampling? I've been sampling for 15 years. 15 years. So we have locations on a canal system where we have 15 years worth of data. But we recommend, and we know what the nitrogen and phosphorus levels are in the canal system. We recommend to our residents that if you irrigate your yard with canal water, you really don't need to fertilize. And I tried it for several years, and then actually it worked. And our nitrogen and phosphorus levels are in the intermediate range in that trophic scale, eutrophic, that Lake Watch recommends for a healthy system.
Yeah, it's a really good point. There's a push to do more accounting for that type of stuff, and I've got some colleagues that are really starting to push for that. Interesting little side story. I'm also doing some work right now in a community in Pinellas County, and it's a neighborhood that has a huge stormwater pond, and all the houses are around the pond. And half of the community, half of the neighbors, for some reason, have chosen to irrigate from the pond, like you were saying, they irrigate from the canals. They, for some reason, irrigate from the pond. And the other half have chosen to use the county's reclaimed water. So it's a wonderful situation to study because I can look at each house, and some are irrigating with pond water, some are irrigating with reclaimed water. And I've been taking some soil samples, and I was expecting the reclaimed water soils to have more nitrogen and phosphorus, but actually pond water irrigated soils have more nitrogen and phosphorus in them, which tells me that that pond water, just like you said, the canal water, is probably supplying everything that grass needs. It was really an interesting observation to me. It's completely opposite of what I was expecting. But yeah, if you're irrigating from a canal or a stormwater pond, very likely are not needing a lot of fertilizer. Yeah.
So you said that septic system, when the water goes through, you want it to be anaerobic. But when it comes through the bottom, coming out with oxygen, or for nitrogen, I'm sorry, for the nitrogen. Or an anaerobic system, like kind of reversing that?
The aerobics, let me make sure I'm understanding your question correctly. So there are aerobic treatment systems. Is that what you're?
Right, but you said that you want low oxygen, or to get rid of the nitrogen, you want it to be anaerobic.
Yeah,
So if you have an aerobic system, would that not be kind of good?
that's a really good question. So your aerobic systems, they are focused on treatment in the septic tank. So there's treatment in the tank, and there's treatment in the drain field. In a conventional system, almost all the treatment takes place in the drain field. But because of how things behave in the soil, we do want that anaerobic environment. Conversely, when we're focused on treatment in the septic tank, an aerobic environment is advantageous because it speeds up decomposition of that waste material, helps break it down faster, which helps us get to just a lower waste volume. So just by having less effluent that then moves out of that septic tank, we're improving the situation. So, yeah, kind of a little counterintuitive, but in the tank, it's good to promote that aerobic environment. In the soils, in the soils we actually need both. We need an aerobic followed by an anaerobic in order to get the treatment that we need. Yeah, that's a really good question.
Same talking about aerobic and anaerobic, now apply to the pond or to the canal. Would you advise to have a very strong aeration in ponds in order to alleviate the anaerobic conditions?
Yeah, so again, ponds, aeration can do a lot for nitrogen removal in ponds. It's often not very advantageous for phosphorus, and then sometimes can actually make things worse for phosphorus. Unfortunately, there's trade-offs, but in most of our cases, nitrogen is the nutrient that we're most concerned about in our coastal waters in Florida. So definitely some aeration to improve nitrogen removal in those ponds is definitely a good thing. But if you get a fountain, remember not all fountains are aerators, so make sure that it's actually an aerator, not just a bubbler fountain. Yeah.
The biofilter comments, would that be applicable to the seawalls up against these canals that go to the harbor into the bay with sawdust?
Oh, could you?
Placements, and then with that, and I think Brandon was in a meeting we had, it seen here a couple of weeks ago, deep-well injection is a piece of this puzzle too, I think. South Florida has mobile zones down there, which they have a place to put water. Not sure about what Charlotte County or Hillsborough County has up that way.
In terms of deep well injection, yeah, I'm not sure either how much you guys are doing that here.
Because AWT, if you listen to Charlotte County's new numbers, they're only up 300%. There's a cost impact on septic at 15 or so thousand versus 20+ thousand for sewer, plus ongoing expenses to maintain these plants. So that's all tied to the ratepayers of the community.
I think I get where you're going. So in other words, there's cost associated either way, right? And we gotta think through the whole system, not just.
They just can't say, okay, sewers are the answer.
Right.
I mean, Brandon knows that better than we do, and
Right.
you do also.
Right.
But,
Yeah.
but I'm hearing numbers, and Brandon's heard them too, 300% increases for AWT in this county is off the chart.
Yeah.
And that's 2030 is, I believe, is the ballpark numbers. That's not right, Brandon?
So it's, provide a little bit of context. Yes, so right now, water that is not put into the reclaim system is disposed of through deep well injection. So there's certain requirements that reclaimed water has to meet in terms of the quality of the water. They can't just take anything that goes to the plant and put it into the reclaim system. So if it doesn't meet those standards, then it goes into deep well injection. The cost of the sewer plants, keep in mind, that gets batted around, it's not just for AWT, it's for expansion of capacity for those plants. That's the vast majority of the expense that is undergone right there. And they're gonna have to do that expansion anyway because of the requirements for all of these new developments coming in to be on sewer. They're having to accommodate the increased capacity from that. So it's really a lot of that that's driving the construction and the cost. The AWT is a cost, but it's a small component. And it's actually, as I understand it, a bit cheaper on the AWT part than the way they're doing it because, when you're doing construction on a plant, you're having to tear up a bunch of stuff, right? So by kind of doing the AWT implementation at the same time they're doing the expansion, they're saving some money because it's similar. There's some common equipment there that they're going to have to tear up when they're doing the AWT versus expansion. So that's why those two, the AWT is coinciding with expansion of each of these plants, and that's a good part of the reason behind the delay for some plants getting AWT versus others. So for those that aren't aware, all that is in process now. The biggest plant, which is in Port Charlotte, broke ground under construction earlier this year. And then they're kind of systematically stair-stepping construction for expansion for each of the other treatment facilities over the next few years. And I think it was 2032, I think is the deadline that we've got to have all this done. So. So yeah, so it's the advanced treatment's coming, but the expansion's coming with it. It's just part of the nature of the fact that county is growing more so than the expanded.
It is, and I think that goes in line with the point that I was making about water supply and water quality being so connected because of our development and our population growth that we're having. We can't separate those.
Mayor, if you're familiar with the Pope Power Station reclaimed water project from Bartow to the plant, it was done a few years ago.
Say that again?
The recycled water plant,
Uh-huh.
the Pope Power Station, if you know that project.
I don't know about
If
that.
you don't fuck with that, was my project, so.
Oh, okay.
It's a national award-winning project, by the way.
Awesome, okay.
Reclaimed water.
Yeah.
On that note, are you familiar with or the ongoing work in Manatee County? I think is it the villages that are doing they're doing treatment of stormwater. So they have a bunch of reclaimed water coming in that's not advanced, and so they're doing pre-treatment of the stormwater ponds using a combination of biochar and wood chips.
Oh, okay.
Cemetery stuff.
Yeah.
To do a two-stage. So biochar is really good for phosphorus.
Yeah.
Downside being there's a capacity limit, and you eventually you have to replace that biochar with natural. Anyway, so have you heard anything about that by any chance or involved with that?
I know some people that are kind of sort of involved with that, but that's like as close as I get to it. If I
Okay.
know somebody or know somebody who's working on it.
Okay, it's one of those things.
Yeah.
Okay.
No, that's pretty cool.
Yeah. I'll try to track down.
I had a question that I got from the walk where you encourage by naturalists to leave litter on your lawn or on your bushes and stuff, so is that a bad thing now? And good for nature to make soil and plants and critters like it? It's not good for the runoff of nitrogen?
As long as it's on a vegetated ground surface or under your trees or in your garden, it's totally fine.
Okay.
It's when it's on streets and sidewalks, it's impervious surfaces, it becomes part of the stormwater flow, that's the problem. Yeah.
Yeah.
Yep, no, I mean, keeping it on pervious surface, that's wonderful. Yeah, which is what we did in my yard for years.
So with that in mind, you have 10 acres of black land, you can poop out on the 10 acres. If you're fronting water, you better pick it up with it.
Yeah. If I had 10 acres, I probably would not clean all that.
You got to go through the
Yeah, if you're waterfront, if you're waterfront. If you are not familiar with University of Florida's Principles for Florida-Friendly Landscaping, just Google that, Florida-Friendly Landscaping Principles. There's like 12 or 13 principles. One of those principles is protect the waterfront. And there are things that we need to do. If you live waterfront, think about what you can do to protect the waterfront. That's definitely one of them.
I think we have time for maybe one more question, and then Mary will be around afterwards to answer. Well, if not, Mary does have her email. She does answer emails. She's very busy. She'll answer all your questions. So
I try.
let's give a hand one more time for Mary. Thank you all for coming, and check out the Conservancy. We have a membership thing you can scan back there to become a member of the Conservancy and keep updated on all the different events and things that are coming up. So thanks again for coming out.
Thank you.
Thank you, Mary.